Hi, today we are going to discuss the second order linear differential equation with constant coefficient. So before we start the second order linear differential equation, I would like to review what we have learned on the last lecture. So on the last lecture, we will learn about the first order differential equation, this one, linear, autonomous, with constant coefficient. So we have y dot equals ay plus b, and the solution is given by yt k times e to the at plus minus b over a, and you know this is the steady state solution. So yt equal this if a is not equal to 0. When a equals to 0, yt is given by bt plus k, and it will converge when a is less than 0. So if we look carefully, the solution of the first order differential equation, it contains a term like e to the at, e to the at. In the second order differential equation, we would like to find solution similar to this, e to the at, something times e to the at. So if we are given the homogeneous differential equation with constant coefficient, this one, remember, if we are talking about non-homogeneous, this should not be 0, this should be a GT. We usually discuss just a polynomial, either polynomial or exponent function. So we discuss first the homogeneous differential equation with constant coefficient given by this, and ABC is just a real constant. So, based on our experience on the first order differential equation, we will guess that the solution resemble or similar like to e to the rt, and we want to know what is the r. So, I would like to substitute this e to the rt to this equation. So before I want to know, would like to know what is y double dot is the second derivative of this. Y dot is the first derivative of this. So if you remember, if I have e to the at, if I want to find the derivative of e to the at, is just e to the at if I want to get the derivative with respect to at. But I want to get the derivative with respect to t, so I have to find the derivative of this with respect to t, that is a. So this is e to the at times a. So the derivative of e to the at is a times e to the at. So if I have this, the derivative of if y equals e to the rt, so y dot, the derivative of y with respect to t should be r times e to the rt. What about the y double dot? Is the derivative of r times e to the rt. So the derivative is given by r times e to the rt. So I've got this one. Y double dot is r squared e to the rt. Y dot is r times e to the rt plus c y is e to the rt equals 0. And I have this e to the rt, e to the rt, e to the rt. I can factor it out. So what it remains in the brackets is just ar squared, br, and c. But you remember e to the rt, e to the t is never 0. E to the at for any given constant a is never 0. So I can cancel it out. So I have ar squared plus br plus c. So we want to find what is r, and r is just satisfying the quadratic equation. This is this quadratic equation is similar to the quadratic equation we have for the second order difference equation, and the name is also the same. It is usually called the characteristic equation. So as in the case of second order difference equation, we will just only discuss the case when the characteristics equation have two different real roots or one real root, or we usually call a double root. Okay, so similar to difference equation, second order difference equation, the solution is given by this. So if I given a times y double dot plus by dot plus cy equals 0, so the solution is given by c1 times e to the r1t plus c2 times e to the r2t. If I have double roots, that is R1 equals R2 equals R, I have C1 times e to the RT plus C2 times t to the ERT. So we would like to look at an example. First, we want to find the general solution of the homogeneous differential equation of this. The same as we usually have for the second order difference equation. We find first the characteristic equations correspond to this differential equation. This is given by r squared minus 3r plus 2 equals 0. So I can factor it out. So I can factorize uh, the polynomial, the quadratic polynomial. So I have r minus 2 times r minus 1 equals 0. So either r minus 2 is 0 or r minus 1 is 0. So r should be 2 or I should be 1. So the solution is given by k1 times e to the 2t r times t plus k2 times e to the t, 1t. 1t is just t. And if I have I have additional questions. If I have initial condition is given by y0 is 0 and y dot 0 equals 1, the derivative of y with respect to t is 1 at t equals 0. We want to find the unique solution. So we want to find what is k1 and k2 in this one if given initial condition. So I can just substitute y0 equals 0. So y0 is just k1 e to the 2 times 0 plus k2 e to the t is just 0. So I have y0 is 0. 0 equals k1 plus k2. For the second initial condition, I have y dot at time 0 equals 1. So I have to obtain what is y dot. So if yt is this, what is the derivative of y with respect to t? Remember, e to the 2t, the derivative of this is e to the 2t times the derivative of 2t with respect to time, that is t, that is 2. So I have k1 times e to the 2t times 2, so I have 2k1 e to the 2t. And the derivative of this with respect to t is just k2 times e to the t. I can substitute t equals 0, and t equals 0 is 1. So I substitute this, t equals 0, t equals 0, so I have this. By using the Cramer rule, I can have k1 is 1, and k2 is minus 1. So the unique solution correspond to the initial condition is given by this. E to the 2t minus e to the t. So for that, we will look at the second example. Find the general solution of the homogeneous differential equation this. And the characteristic equation correspond to this differential equation is given by r squared plus 6r plus 9 equals 0. So I have r plus 3 times r plus 3 equals 0. So r plus 3 should be 0 or r plus 3 should be 0. But this is all the same. So r equals minus 3. So I only have one root. So we usually call this a double root. So the general solution is k1 times e to the minus t3 times t plus k2 times e to the minus t. Don't forget, just as the case of difference equation, we multiply by t. Okay, yeah. So if initial condition is given by y0 equals 0 and y dot 0 equals 1, find the unique solution. The same procedure. We substitute y0 equals 0, y0 substitute 0, 0, 0, 0. So this will become 0. So I have k1 e to the 0 should be 0, e to the 0 should be 1. So this is k1 times 1. So I have y0 is 0, 0 equals k1. So yt is just remain k1 is 0. So yt is just k2 times t times e to the minus 3t. So to substitute the second initial condition, I have to know what is y dot t. So y dot t, don't forget, this is u times phi. So the derivative will be given by u prime phi plus u phi prime. U prime phi k2 times t, the derivative of this is k2 times e to the minus 3 plus u phi prime e to the minus 3t times the derivative of this is just minus 3t. Okay, and I can substitute t equals 0. When substitute 0, I have k2 e to the minus this one, and this will become 0 apparently because this is a multiplication with 0. So I have k2 times, and this becomes 1. So this is k2 times 1, just k2, and y dot 0, 1 is 1, so it is equal 1. So the unique solution corresponds to the given initial condition is yt equals t times e to the minus 3t, because k2 is just 1 and k1 is just 0. So that's all for the solution of homogeneous second order differential equation with constant coefficient. We can compare it with the solution of homogeneous second order difference equation with constant coefficient. So if I have this one the same, you look carefully, this is a yt plus 2 plus b yt plus 1 plus c yt equals 0. The same abc is just a real constant. If the characteristic equation a r squared plus br plus c have two different real roots, maybe as r1 and r2, so it is given by k1 times r1 to t plus k2 times r2 to the power of t. And the same for the double root, I have k1 r to the t plus k2 times, don't forget, t times r to the t. So it's similar, don't forget, but in the homogeneous second differential equation, the solution contains e to the rt. But in the homogeneous difference equation, it contains r to the t, So it's similar to the first order differential equation, e to the something times t. First order difference equation, a r to the power of t. Okay, yeah. So now let's discuss the solution of non-homogeneous second order differential equation with constant coefficient. The non-homogeneous, we have gt, this one gt is not equal to 0. So the solution of non-homogeneous second order differential equation consists of two parts. That is yt equals yt home plus yt particular. Home, it means the homogeneous. Par, it means the particular solution. So we will use the same technique as we have used at the second order differential equation, the method of undetermined coefficient. And we have the special gt. The special gt is just a polynomial. Don't forget, this is a polynomial of order 2. The highest power is 2, so this is a polynomial of order 2. And this one is polynomial of order 1 with because the highest power is just 1. And second, gt can be exponent, e to the 2t, e to the 3t, e to the minus 2t, etc. Don't forget, e is just a constant, 2.7218 or something like that, just 2 point something. So we will just gonna discuss a certain gt at this business mathematics 2. Okay, so let's have a look at the first example. The first example is y double dot minus 4y equals minus 12 times e to the 3t. Given the initial condition, y0 is 1 and y dot 0 equals 0. So we want to know the solution of this non-homogeneous differential equation. So the solution can be given by yt equals yt home plus, sorry, this should be yt par. And to find the yt home, we consider the homogeneous solution. That is y double dot minus 4y equals 0. So the characteristic equation correspond to the homogeneous differential equation is r squared minus 4 equals 0. So I have this one. So I have r equals minus 2 or r is 2. So the homogeneous solution is given by C1 times e to the minus 2t plus C2 times e to the 2t. So this is the homogeneous solution. And so we end with the homogeneous solution, this one. To find the particular solution, we let yt par is a multiple of the essential function of this. The essential function of gt is just e to the 3t. So the essential function is t to the 3t. So the yt par should be a constant times e to the 3t. Don't forget, just the same as the second order difference equation, if gt is e to the 2t, or if gt is e to the minus 2t, that is gt is a multiple of the homogeneous solution, we have a kind of different yt par. Why? Because the yt par should be multiplied by t. Okay, we will look at it at the second example. Okay, we'll carry on. So yt par should be k times e to the 3t. So I want to substitute this to here. So I have to find what is y dot, the derivative of y with respect to t par. What is y double dot t par? You know that if yt par is this, so y dot should be k times e to the 3t times 3. What about y double dot is k times e to the 3t times 3 squared. So I have, okay, so I can substitute. So I have this, and you have e to the 3t, e to the 3t. Okay, you can, this, you have k times e to the 3t, k times e to the 3t. I can factor it out. So what remains is 4 times 3, that is 12, minus 4 times 9, that is 36. Times k times e to the 3t, this is minus 12 times e to the 3t. So I can cancel out e to the 3t because e to the 3t cannot be 0. So I have, this is minus 24 times k equals minus 12. So I have k is minus 12 divided by minus 24, that is k equals a half. So the particular solution is given by this, a half t e to the 2t, because k is a half here. Oh, sorry. So it should not be, so this is a mistake. You shouldn't have t. Because this is just k times e to the 3t. So it's just half times e to the 3. So this is a mistake, sorry, yeah. So this one is right. The homogeneous solution plus a half e to the 3t. This is wrong. This is wrong. So it will be a half e to the 3t. This is right. Okay, yeah. So now if we want to find the unique solution, if given y0 is 1 and y dot 0 is 0, I can, y is this, so I can substitute t equals 0 to this equation. So I have this, and y0 is just 1, e to the 0 is 1, so c1 times 1 is c1. This is e to the power of 0 is 1, so I have c2 times 1 is c2. So e times 3 to the 0, 3 times 0 is e to the 0, so this is just 1, a half times 1 is just 1. So I have this, I can get a half to the left hand side, so I have a half equals c1 plus c2. I can substitute this initial condition to this, but we have to find what is y dot first, the derivative of y with respect to t. Don't forget, what is the derivative of this with respect to t? c1 times e to the minus 2t times the derivative of this with respect to t, that is minus 2. What is the derivative of this with respect to t? c2 times e to the 2t times t, times 2. Plus, what is the derivative of this with respect to t? A half times e to the 3t times 3. So I have this one. And y dot 0, I can just use, this is will become 1, this will become 1, and this will become the 1, and I have this. and I get 3 over 2 here. So I have these two equations in C1 and C2. I can use the Cramer rule, and I can find that C1 is 5 over 8 and C2 is just minus 1 over 8. So the unique solution is given by this. Okay. Then the last one, for the second example, find the solution of the given differential equation, second order. This one, y double dot minus 4y equals 5 times e to the 2t. Difference from before, the gt contains the homogeneous solution. y0 is 1, y dot 0 is 0. Okay, let's take a look. So the solution can be written by the same yt home. Don't forget it's the same. This is yt par. Finding the homogeneous solution of y double dot minus 4y. So we are looking at the homogeneous. So this should be 0. So we want to find the characteristic equation, the same as before, and the same as before, and the same as before. But for the finding the particular solution, I have yt par should be k times e to the 2t. Don't forget we must multiply by t. Why? Because e to the t is just a part of a homogeneous solution, this one. So I have to multiply with t in order to become different with yt home. So if I have yt par is this, I want to find what is y dot and y double dot. What is y dot? Y dot is the derivative of this with respect to t. Don't forget what is the derivative of this with respect to t. I can look at this as u times phi. So the derivative is given by u prime phi plus u phi prime. So y par should be u k u prime, that is k, times phi e to the 2t plus u kt times phi prime. Phi prime is t to the 2t times 2. I can get 2 in front. So I have 2kt e to the 2t. And I can do the same trick for the y double dot. This is just 2k e to the 2t, but this one, this is u phi. So the derivative is u prime phi plus u phi prime. So this one. So this one 2k e to the 2t, 2k e to the 2t. This is the same 2k plus 2k. This is 4k. And this is 4kt e to the 2t, 4k e to the 2t. I can substitute this to the non-homogeneous differential equation. I have this one. This one, y double dot minus 4 times y. Y is just this. Equal 5 times e to the 2t. So I have, don't forget, this cancels out 4kt e to the 2t minus 4kt e to the 2t. So we just left 4k e to the 2t equals 5 e to the 2t. E to the 2t never zero. So I can cancel it out. So I have 4k equals 5 and k equals 5 over 4. So the particular solution is given by this. So the general solution is given by this. Okay, yeah. So is it finished yet? No, it's not finished. Why? Because we want to find what is the unique solution given the initial condition. So you can just do it on your own. So read about this chapter application on the price adjustment model in the textbook. Okay, thank you.